Yeah. Yeah, good afternoon all. So myself, I'm Vijay. I hold like 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment. As part of today's demo, I'll be covering the following topics. So before I start, can anyone please confirm whether my voice is clear, right?
Yes.
Fine. So what is big data? So it's a demo on big total Hadoop and PySpark, Spark with Python implementation, right? Yes. What is big data and why Hadoop? Drawbacks with the current databases, advantage of Hadoop and Spark, and Hadoop and Spark job market, right? So big data, right? Like huge volumes of data. So if take that how the data is stored currently, right? Data storage units like KBs of data, MBs of data, GBs of data, terabytes, petabytes, exabytes, zettabytes, etabytes, and sottabytes, right? So you should have seen KBs, MBs, GBs, or even TBs of data, right? But do you think like petabytes, exabytes of data, is it getting generated in the current real world? If so, examples of petabytes of data generation, yes? If petabytes of data generation, examples of petabytes of data generation, right? 1 petabyte equal to 1024 TB. 1 petabyte 1024 TB, right? If you take example of any banking sector like SBI or HDFC, right? Within the city, we see hundreds of branches for it. Within the state, we see thousands of branches for it. Within the entire country, we see lakhs of branches. Again, in each branch, we see millions of customers, each customer making multiple transactions per hour, per day, per week, per month, per year, right? Each and every transaction has to be stored. So huge data is getting generated, right? So forget about this. Like we have got social media like Facebook, right? Which has got users, which has got users throughout the world, right? Not only within the country, it has got users throughout the world. Facebook, millions and trillions of users for Facebook, millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? Each and every post has to be stored, right? What should be the storage capacity of Facebook, right? For storing these videos or posts. Not only like Facebook today, if you see every application generating huge data, right? Every application generating huge data. If I take 1 minute transaction, in a minute, how many Facebook posts? In a minute, how many Twitter tweets? Like everyone, you are querying in the Google, right? What should be that? What is the data generated by Google in a minute? And everyone you are creating your own videos and uploading in the YouTube, right? YouTube videos upload. What should be the storage capacity to store all the videos, right? And email messages or email or Gmail messages, right? Right. Or what should be the storage capacity to store all the millions and trillions of messages, right? And if it just now I was talking about the bank transactions, right? And also like telecom transactions here, everywhere we see like huge data. And even if you talk about the e-commerce sites like Amazon, Flipkart, all this, they're generating huge data. If we talk like Google and an average generating more than 450 petabytes per month and an average, right? 450 into 1024 TBs, the data generated by Google and an average, right? So not only this, if we talk about various other applications also generating huge data. So currently we have got a databases, right? Like Oracle, MySQL, DB2, SQL Server, right? These databases, they are used for online transactional processing, OLTP, online transfer for day-to-day operations, right? These databases, okay. And we have got some specialized databases, if you heard about that, like Teradata, Netija, Vertica, right? These databases, used for data warehouse purpose, right? But this databases or specialized databases can handle data up to some extent. That too structured data. They can handle what? Structured data. They cannot handle unstructured or semi-structured kind of data. And that too, if you see the storage system day by day, right? It is increasing a lot. If you see, if we compare from the last 40, 50 years, right? This is your data in the entire world. This is the data in the entire world, right? Yes. Okay. Which got generated from the 1973 to 2023. If we talk from last 10 years, 2013 to 2023, compare the last 10 years with the previous 40 years, right? So nearly 20%. 20% we see in the last 40 years, but 80% of the data what we see in the current world has been generated from the last 10 to 15 years, right? Previously, there was very less data, and that too the data was too small, like in KBs, MBs. Reasons for huge data generation, especially from the last 10 years, right? Because of usage of technology, usage of internet, everyone using internet today. Usage of smartphones, right? Yes, usage of smartphones. Today, everyone using smartphones, everyone using internet, everyone using the technology. So data is generated a lot, right? Now, even if you see previously in 1990s, floppy disk 1.44 MB, the storage, right? Now you cannot even store a smartphone pic in it. But previously in this floppy disk, you can store in KBs, right? Nearly 40 images can be stored, right? Previously. Now, one not even a single pic you can store, right? Today we got compact disk, right? Next to USBs, all this, right? And what are the main sources from where this data is getting generated? What are the main sources? Mainly three sources, right? Mainly three sources from where this data is getting generated. Firstly, the data gets generated from social data. That is what? Social data, nothing but data which got generated from social sites like WhatsApp, Facebook, all this, right? Second, like machine data, data which got generated by reading, scanning the RFID chips, barcodes, right? We call such data as machine data. And next, like transactional data, day-to-day operations like bank transaction, telecom transactions, all this, right? So mainly the data is getting generated from these three sources: social, machine, and transactional data. And these types, what are the types of data, right? Types of data. See, three types. Here also like three types, like structured, semi-structured, and mainly like unstructured. Structured, semi-structured, and unstructured. Structured means data which is organized in the form of rows and columns in a structured format, right? In the form of rows and columns. Semi-structured data, right? Semi-structured, which is not fully structured, which is not fully unstructured. Unstructured data, like articles, short messages, images, videos, all this like unstructured. So databases can handle only structured, they cannot handle semi-structured, unstructured kind of data. So as a solution to all these storage level problems and processing level problems, right? We have got a framework called Hadoop for huge data storage and huge data processing. Hadoop is providing two services: huge data storage and for huge data processing. Huge data storage and data processing, right? Hadoop is for two things: storing and processing, right? Generally, if you talk any technology, either like C or C++, Java, .NET, all these, they are used for processing purpose. Or if you talk like databases like Oracle, MySQL, DB2, for storage purpose. But for Hadoop combines both storage and processing. It is meant for both storing and processing. Storing the data and processing the data. So for storing the data, does Hadoop use any database internally for storing its data? No. Databases has got some drawbacks. Despite of those drawbacks, still Hadoop doesn't go with databases for storing data. It is going with a kind of file system called HDFS, Hadoop Distributed File System. And for processing, we have got MapReduce, and currently we are using a very high speed processing model like Spark, right? Both are used for processing, right? So Hadoop for two things, storing and processing. Then you may get one query, right? When Hadoop in the market, when it can process in a high speed and it can store huge data, and that huge data storage and processing, why again is this processing technologies will be going away from the market when Hadoop can able to do all the storage and processing works? No, still they will be in the market. C, C++, Java will be doing their work, but Hadoop is meant for batch application, for batch processing. You need to understand clearly. Hadoop or Spark is meant for batch applications or for batch processing, not for online transactional processing. Hadoop is not for online transactional processing. Okay. Just observe this. Hadoop is for batch. Just observe this, right? Yes, three sources of data is said: social data, machine data, and transactional data. And types of data: structured, unstructured, and semi-structured. Hadoop meant for storage. We use HDFS, and processing, MapReduce or Spark. Hadoop is not for online processing. Hadoop is for batch applications. Hadoop is not for online. Hadoop is for batch applications. There are two types of applications: online and batch applications. Online applications means user interactive application. Online means user gives the input compulsory. Here user has to give the input. User interactive applications, online applications. Whenever you are transferring some amount to your friend, means user gives the input here. User interactive application, or booking a movie ticket, user required. Making an online transaction, right? User required. But batch application means user non-interactive, right? Yes, user non-interactive application. Can anyone say the example for this batch application, right? Yes. User non-interactive application. User is nowhere required. I want the sessions to be interactive, right? You can just unmute yourself and give your responses. And also you can type in the short panel, right? User non-interactive. User is nowhere required, such kind of applications. Okay. Example of user non-interactive applications means, for example, railway ticketing PNR status, right? Currently your status is 200. After 1 hour, it is 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Means here user is nowhere required. User doesn't give any input here. Everything happens here in the background. Okay, user non-interactive application. For example, yes, Dildo metro timings, right? And user non-interactive, one more example is credit card statement generation for millions and trillions of customers, where user input is not required, user is nowhere required, and mobile phone statement generation for millions and trillions of customers, right? Where user input is nowhere required. So Hadoop is for batch kind of application, not for a single transaction. If you are making, no need to go for Hadoop. For millions and trillions of records, right? For millions and trillions of records, we can go for batch applications for Hadoop. Yes. So Hadoop is for batch application. Now, what are the drawbacks? Now understood it, everyone. What is the services provided by Hadoop? Why Hadoop required? Right. Now, next. You may get some queries. Why databases? What are the drawbacks with the databases? Current databases. Why databases? Drawbacks with the current databases. Why databases can't be used for storing Hadoop's data? Why databases? Why the okay? Why databases like why databases like Oracle cannot store Hadoop's data? Cannot store Hadoop's data. Yes, sir. I was saying the same. Database can store structured data, but semi-structured, unstructured kind of data it cannot handle, right? But today, if you see, the biggest challenge today is most of the data will be in unstructured format. We need to make it structured. Right. So one by one drawbacks with the current databases and why databases are not used for storing Hadoop's data means limited storage in GBs or in TBs. No parallel processing in most of the databases. And see a labor example, right? Labor example. Volume increases means speed decreases. Volume increases, speed decreases. If we give a labor example, a small as a boy going to school, right? With a bag. Bag size 5 kg. Your bag has the weight of the bag is 5 kg, right? Okay, he can run with that. The boy can run to school with the weight. But if you increase the weight to 20 kgs or 15 kgs, right? He can walk. He cannot run. He can only walk. But if I increase that to 50 kg, right? He can't even walk. Means what is your observation here? If volume increases, speed decreases. But here to justify this, right? I give one more example for this. As volume increases, speed decreasing. Okay, why data? Okay. No parallel processing. As volume increasing, speed decreases. And one more, see this example, right? Select sum of amount. Select sum of amount from sales one has got 10 records. Total amount of from sales to, right? It has got 1 lakh records. Select standard, okay, select sum of amount from sales. Sales one is one table, sales two is one table, sales three in one table. It has got 10 records, it has got 1 lakh records, it has got 1 crore records. Okay, which query is going to execute faster among these three? Yes, everyone. Which query executes faster among these three? Sum of amount of 10 records, sum of total amount of 1 lakh, total amount of 1 crore. Obviously, the first query, right? Obviously, I want more interaction. I want some kind of interaction from you, right? Responses, queries, all those. Fine. Sum of amount from sales one, 10 records, 1 lakh, 1 crore. First query executes faster because total amount of only 10 records, right? So query to query as the volume increasing, query to query, right? As the volume increasing, speed decreasing, right? Yes. Even if complexity increases, speed decreases, right? If complexity increases, speed decreases, right? Yes. Complexity increases means, for example, what is 3 into 2? Immediately we'll say 6. 5 into 6. 12 into 8. 96. It takes a little bit time. 13 into 23. 352 into 786. Means here immediately you said immediately. It will take a little bit time. Here taken more time, right? Complexity increasing, speed decreases here in the same way. Observe this example, right? Select total amount from sales one, 1 crore records. Average amount from sales, 1 crore. Standard deviation of amount from sales, 1 crore. So here, total amount, average amount, and standard deviation of amount. Same table, right? Which query executes faster among these three? Okay. So which query executes faster? Sum, average, standard deviation. Obviously, the first query because sum is a yes, because average is a two-step process. First sum has to be calculated, next average has to be calculated as compared to the first one, right? Average, the second query takes more time. First compared to that with the third, right? Standard deviation, lot of internal processing required. Sum of amount, average amount, standard deviation. Query to query as the complexity increases, speed decreases, right? In case of right, and databases can handle only structured. Databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. For example, if you want to take reviews for a particular movie, right? If you want to take reviews for a particular movie, data is in this way. The user and review, giving review, right? Yes. Observe user 1, user 2, user 3. In this way, 100 users giving the first person saying the movie is good, second person saying the movie is not good, third person saying the movie is good. In this way, saying in the form of ones and zeros, right? If movie is good, saying 1. If the movie is bad, saying 0, right? They're giving feedback in the form of ones and zeros. Can you write an SQL query to count the number of ones and zeros here? Can we write an SQL query? Single grouping, single aggregation, right? Count aggregation. You can just count this ones and zeros, right? Select. Review wise count star. Select review wise count star from reviews. Select review wise count from reviews, group by review. The output you will get in this way: review 1 and 0. 90 saying the movie is good, 10 people saying the movie is bad. So it's groups all that, right? 1 how many? 90. 0 how many? Right. Yeah. Single grouping by single field, single aggregation, count aggregation by this. Now, but generally the reviews won't be given in zeros and ones, right? They will provide in their own movie is good. Second person saying the movie is not good. Third one saying movie is. They are giving in their own text form. Can you write an SQL query now to count the number of goods and number of not goods? Okay, 90 people saying it's good. Then can you write an SQL query for this? Means not possible, right? Not possible. But even if you want to write by using keyword count, good, how many times the good has occurred? It use wrong computation as because not good also having good within it. Yes. So these are the drawbacks. Despite of these drawbacks, so Hadoop doesn't use databases for storing its data. Instead, it's going with a right. Yes. So what are the drawbacks? Limited storage in most of the databases. No parallel processing. As volume increases, speed decreases. Complexity increases, speed decreases, right? And databases can handle only structured data, right? Yes. Okay. So these are the drawbacks with the databases. Before I go with Hadoop advantages, you need to know something about the Hadoop architecture, right? Yes. Later I discuss much about this storage architecture, processing architecture, Hadoop architecture, right? But here, just an overview. Hadoop doesn't follow client server architecture. It won't follow client server or request response architecture. Whenever client giving a request, this kind of architecture is not. Hadoop follows master slave architecture. It follows what? Master slave architecture. Once again, can anyone please confirm whether my voice is clear?
Yes, sir.
Yes, fine. Yeah, 1 second. Hadoop cluster. We say Hadoop cluster. There are two types of clusters: single node cluster, multi-node Hadoop cluster, right? So what is a cluster means? Group of nodes. Nodes nothing but CPUs connected in a network. Group of node CPUs connected in a network. There are two types of nodes. Master node, slave node. Master node and slave node. Master node, slave node. Yes. So observe this diagram, right? Yes. Single node. This is master node. These are slave nodes. Slave 1, slave 2, and slave 3. S1, S2, S3, right? Yes. So here single master and multiple slaves, right? Single master and multiple slaves. In Hadoop, data is stored in the form of files f1.txt, f1.txt, right? Yes. The file is divided into smaller parts, right? Like this. Each part is going to be stored in one slave. Each one is going to be stored in one slave. Yes, each one is stored in one slave. Yes. File divided into multiple parts, they are stored across the multiple slaves, right? So here, who stores the data? Slaves. Who process the data? Slave. And what master does? Divides the file into multiple parts and stores across it, and assigning T1 task, T2 task, T3 task to this. Assigning T1, T2, and T3 tasks. T1, T2, and T3. T1 task assigned to S1, T2 task to S2, T3 task to S3. 3 tasks are assigned to 3 slaves. Who does this? Master. When these 3 tasks are executed by the 3 slaves, suddenly if one slave goes down, as these are machines, if any one machine goes down, right, then the task of it is assigned to any of the available slaves. This process is called as fault tolerance mechanism. This process is called as fault tolerance mechanism, right? Yes. Right. Okay. So what is master node responsibilities? What if master goes down? Yes, good query. So what if master goes down? So in the just like in the absence of the principal, we have vice principal, right? Here also, in the absence of master node, we have got secondary name node. In the absence of, yes, we have got secondary name node. Yes. So what are master node responsibilities? Task assignment, assigning tasks, balancing the load to each and every slave, load balancing, fault tolerance, health monitoring. So these are the master node responsibilities. Slave node stores the data and process the data, right? So this what, so before I go with Hadoop advantages, you need to know something about this, right? Now see the Hadoop advantages. Unlimited data storage because of horizontally unlimited scalability. Unlimited data storage because of horizontally unlimited storage. Very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured. Open source, no licensing required. Commodity hardware means it doesn't mean that you need to have very high configured, right? No. Yes. So unlimited data storage because of horizontally unlimited scalability. What do you mean by horizontally unlimited scalability? Observe here, right? In Hadoop, single master, multiple slaves. Today you are running a business with less number of slaves, right? If you are running a business with less number of slaves. Your business has increased, your branches have increased, your data is increased, your customers are increased, right? So when your data is increased, you cannot go with the same number of slaves, right? So you need to increase the slaves also horizontally. Horizontally unlimited number of slaves allowed in the case of Hadoop, right? So here you can make 10 systems if you're running currently. Horizontally, you are increasing to 100, right? Your data increasing. If data increased, if your customers increased by 100 times and data increased by 1,000 times, you cannot go with the same number of slaves. You need to increase it, right? Yes. So very high speed processing because of parallel processing, right? So your data is distributed across multiple systems. Multiple systems are going to store and process it parallelly, parallel processing. And we can handle all varieties, structured, semi-structured, unstructured, open source, no licensing required, right? Fine, right? This is what advantage of Hadoop. So Hadoop is proven in the market storage point of view and processing point of view, right? Storage point of view and processing point of view. So here, if you observe, Yahoo has performed a test. It has taken a table of size 100 TB, consisting of 1024 columns, right? Yes. Sorting based on 16 columns, right? Sorting based on the task is sorting based on 16 columns. It has taken a table of size of this 1024 columns and sorting based on. Yes, we can have also, yes, Om Prakash, right? We can also have backup. We can also set. These are like replications, duplications, right? I'll discuss it. So Yahoo has taken a table of size 100 TB consisting of 1024 columns. Task sorting based on 16 columns. What is the time taken by different databases? Oracle has taken nearly 3.5 days to process this 100 TB data. MySQL has taken nearly 6 days. Right? MySQL has taken nearly 6 days. Teradata has taken 4.5 hours. Say, data warehouse kind of technology. Yes, true. Netija, 3 hours. Finally, Hadoop has taken 3.4 minutes. Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netija has taken 3 hours. Fine. Hadoop has taken just 3.4 minutes, right? This is what's the speed of Hadoop as compared with other things, right? Latest version of Hadoop has just taken only 1.2 minutes, right? Yes. 1.2 minutes. So Hadoop is proven in the market. Processing point of view, even storage point of view also, Hadoop is proven in the market. You may get a query, right? Why databases like Oracle cannot support unlimited storage? Databases like Oracle, why it cannot support unlimited storage? Why it cannot support unlimited? Why only Hadoop can store unlimited storage? There is a limitation, right? On the for the databases. Max limit on the number of. Is a limitation, max limit on the number of slaves. Oracle can go with maximum 256 slaves. MySQL can go with maximum 54 slaves. MySQL Express can go with 256 slaves. SQL Server with 256 slaves. DB2 with this. Teradata with 512 slaves. Netija also 512 slaves. Vertica also will is taking 512 slaves, right? Okay, but currently Teradata and Netija are supporting 1024 slaves. Teradata and Netija, they are supporting 1024, but still we cannot say it as unlimited storage, right? If they get filled, we cannot support data further. But there is no limitation on the number of slaves that Hadoop can have, right? There is no limitation on the number of slaves that Hadoop can have. It can go with any number of slaves. There is a limitation on this databases, right? Yes. Just 1 second, give me a second. Yes. Sorry, yes. So there is a limit on what? Yes. So we need to clearly understand when to go for Hadoop, when to go for other things. For millions and trillions of records, right? For a single transaction, we won't go for Hadoop, right? Hadoop is good for huge data. Hadoop is bad for small data. For small data, splitting it again, storing across multiple systems, processing it like time taking. For only for huge data, Hadoop is good. For small data, Hadoop is bad. So here, this database has got some limit, but there is no limit on the number of slaves that Hadoop can have, right? Yes. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, Yahoo going with 12,000 slaves. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, Facebook going with 42,000 slaves for storing its data, right? When first time implemented, right, it used 8,000. Currently, it is using 42,000 slaves for storing its data. Yes. So just 1 second. we'll be having this for 2 hours, right? The demo will be for 2 hours. So 1 second. So some of them, as they are asking, what is the course content will be discussed as part of this course, right? So both Hadoop and Spark with Python implementation, right? Yes. So you'll be discussing big data Hadoop, lattice Hadoop sources, comparisons, right? HDFS, Hadoop distributed file system in brief. Map reduce execution model up to what required. So map reduce execution model. Scoop, SQL plus Hadoop. The first two characters of SQ and OOP, right? Scoop, SQL plus Hadoop for import and export operation, for importing data and exporting data, for import and export operations, right? And also before data coming to this Hadoop environment, right? Yes. We perform various transformations, other things, right? Yes. Yarn, yet another resource negotiator, yet another resource negotiator. So Yarn artificial components, replay application manager node. So about Yarn and NoSQL database, not only SQL, different types of NoSQL database. As part of the course will be discussed as HBase, right? And one of the important major component of Hadoop, Hive, for data warehouse kind of environment, right? We'll be discussing in brief on Hive, right? What are the Hive components, Hive tables, internal, external, working with XML data, JSON data, URL weblog data, and right? Hive UDF, Hive UDAF, Hive UDTF, right? Yes. And performing tuning mechanism, right? Indexing, bucketing, partitioning, static partitioning, dynamic partitioning, multi-column partitioning, right? All this. And coming to the PySpark, right? In brief, PySpark very high. We have got very high demand on PySpark, right? Very high speed processing. PySpark introduction, right? PySpark RDD computations, right? Persistence options, memory only, and disk only, disk underscore is PySpark core computations, fault tolerance mechanism, groupings and aggregations, multi-grouping, various actions and transformations, different types of action with many working examples, and PySpark SQL data frame, making the data structured and working on it. Various PySpark functions, PySpark SQL functions, built-in functions, PySpark built-in functions, right? Yes. Okay. PySpark external sources, working with SQL statements, Spark and Hive integration, MySQL integration, CSV files, JSON files, transformations, narrow and wide transformations, adding of new columns, dropping of columns, adding new rows, dropping rows, right? Yes. Deployment modes, local mode, clustered mode, local mode and clustered mode, right? Yes. PySpark application stages and tasks, driver and executor, building Spark applications, performance tuning, PySpark streaming concepts, integration with Kafka, this machine learning library. This is what we'll be discussing in brief. PySpark.
So, Vijay, do we have any hands-on for Python, PySpark?
Yeah, PySpark totally. I'll be briefing. You have many working examples. Everything will be hands-on only, right?
Okay.
I'll be just brief.
All right.
That's why it's a 12 weekends batch, right? So it's for 3 months. We'll be discussing this.
Okay.
Yes, we'll be discussing in brief, in depth. Is if you see all these things, right, in brief, in depth, you can compare with the other training sites, right? We'll be having in-depth knowledge on this PySpark. You'll have great comment on this. Not only this, like Hadoop also will be discussing in brief. Yes. Hive, especially in Hive, lot of queries will be asked in the interviews. So we'll be discussing more. I'll be spending more time on Hive and the components which mostly used in the industry, right? I'll be concentrating more, right? With many working examples, right? Yes. So yes,
Hi, sir. This is Mukund. So I am a fresher. To 2020 completed. I have BTech. So I just wanted to know, like, how can I put this in on my CVs to get the job?
yes. So this whatever knowledge I'm providing, right? So at the end of the course, right? You will gain like a typical 4+ experience to get how much knowledge, yeah, that much of knowledge people will be getting. So you can also go with 4+ years of experience, right? After learning this Hadoop and Spark, and even if you see, go and just Google and check, right? The Java opportunities for especially Spark, Hadoop, and both Hadoop also required. Spark, PySpark, right? Very high boom, right? People who has got a great command, definitely you can go through the process, interview process, right? Yes, we'll after learning all this with many working examples. So when clear notes I'll be providing, right? The clear notes also. We just to go through that. 1 second. Observe this. This is the previous 1 second. Observe clear notes like this, like PySpark. Even I'll be discussing some basic Python before I go with the practical part. So clear notes for topic wise, I'll be just providing you like this.
What will be the job role?
And you'll be getting this. You'll be getting the recorded video of the session, even if you're absent because of some ill health or because of some office work, right?
Yes.
Yes. So here you'll be going as a data engineer, right? Data engineer, Spark developer, Hadoop developers, Hadoop and Spark developer, right? So you'll be, yes. If someone was asking, right? MapReduce we would be doing using Java or Python, right? So MapReduce is a component which is mostly used in the previously in the year 2013, 14, 15, 16, right? 11, 12, 13, 14, 15, up to 16, right? MapReduce has got great boom. But once Spark MapReduce got outdated today, right? MapReduce has got outdated now. No one, it's not used. We used to have Apache Pig also, it got outdated. Those components, right? We're not discussing a lot, but MapReduce I'll give the knowledge because total Hadoop has got MapReduce execution model. So I'll give you the knowledge on this MapReduce. Yeah, MapReduce, how this is going to happen, right? But more concentration on Spark and Hive, Scoop, these things. Those are the components which are mostly I discuss more on mostly used components. Right.
So,
So
is there any prerequisite to learn these technologies like Hadoop and
so
PySpark?
yes, if anybody, so basic Linux knowledge is required. Even if it doesn't have knowledge on Linux, I can just brief you. I'll take some 3-hour session on that, on all these comments, right? Linux comments, so that you'll get the idea about it. Basic Linux comments knowledge is required. Basic SQL knowledge is required. And basic Python knowledge also required, right? Even for Python, you have what some time. It's like 1 month of time. By the time we go with Spark with Python implementation, by the time we can just update with Python. Now we won't touch Python now, as we are going with Hadoop first. First 1 month, I'm not going to touch it. After 1 month, like Spark with Python implementation, basic Python knowledge is enough. Even I'm starting a batch on Python also, right? I'll be discussing a batch on Python on Tuesday, 9 p.m. Today is Saturday, right? Tuesday in evening, 9 p.m., 9 o'clock, right? There's a Python core advanced batch. You'll have knowledge on Python, right? Yes, Python also has got a great boom today's market, where widely used today in especially in data science implementation, in this Spark, big data Spark implementation, writing automation scripts in IoT robotics, and also web applications creations in, right, in all these things, right? Widely used. Yes. Yes. So previously Java was mostly used for Hadoop environment, right? But the usage of Java is decreased because of huge codings of Java, right? Huge codings. So MapReduce lot of examples used to discuss, but now that component is outdated. It's not that we will be discussing more time on it, but I'll be providing knowledge on it, right? So basic Linux, basic SQL, basic Python knowledge required. So people, especially if you see the salary packages for this big data guys, right? The big data or this data engineering guys, right? It will be 1.5 times more than the other technologies. At the same time, you need to have the command on this technology when you go to the interview. You can demand for the salary, but at the same time, they need to have the command on this, right? So actually, it's a weekend batch, right? As it's a weekend batch, so we do one thing. We'll have a break of 15-20 minutes, and again we'll continue for 1 more hour. How exactly the data storage and processing is happening within this Hadoop, right? Just we'll have a break for 20 minutes, right? And we'll continue for 1 more hour. This is what the course content I'll be discussing. Just I'll keep the meeting in mute and we'll come back. It's like 4:20 now, right? 20 minutes from now. Like we'll meet at 4:40, right? 4:40. Just I'll keep the meeting in the mute, right? And we'll resume the meeting after 20 minutes. We'll go for 1 more hour, right?
Take 10 minutes only.
Yes, it's time is like we'll meet at 4:40. 4:40, right? Yes. How exactly the data storage, how exactly data stored and processed, right? How exactly data stored and processed in Hadoop. Data is stored in Hadoop, data is stored in the form of files. Yes, in Hadoop, data is stored in the form of files. Again, each file is subdivided into blocks. Each file subdivided into data is stored in the form of files. In database, in the form of tables, in Hadoop, in the form of files. Each file is subdivided into blocks. Default block size 64 MB. Default block size is what? 64 MB. In latest versions, block size, default block size is 128 MB.
Sorry to interrupt, sir, but I didn't understand what is Hadoop actually and what is the use. Why? Because of like unstructured data, we use the Hadoop system. Okay. So is there any kind of server or something like that which can, yeah, this is the Hadoop system. I didn't get actually.
So Hadoop meant for what means? For huge data storage and for huge data processing.
Okay.
For huge data. See, you should have seen in C or Java how much data you have handled. But millions and trillions of records in data in TBs and petabytes. Yes.
Yes.
For that you go for Hadoop. And for data in petabytes, TBs are in petabytes. Processing it, right? So that TBs or petabytes of data you are going to split and you are going to store across multiple systems and processing it parallelly.
Okay. So it's a one kind of a storage system. So where the data will be storage in terms
Storage
of
and processing. So generally any technology performs either storage or processing, right? Databases for storage and some processing like C, C++, Java, right? So they are used for processing, but Hadoop combines both. It is used as a storage and also as processing. That too huge data storage and huge data processing, that too in quick time.
okay. So for storing the data, we need the PySpark, and for processing and storing.
For processing of you go for PySpark. For storage, this Hadoop HDFS is.
Okay. Okay. Yeah, I got it. Thank you.
Yeah, 1 second. Observe this. In Hadoop, data is stored in the form of files. Again, the file is subdivided into blocks. What is the size of each block? 64 MB previously. Now, latest, we are using 128 MB as the block size. For example, I got a file, 200 MB its size. Size is 200 MB. Default block size 64 MB. Assume that default block size 64 MB. Number of blocks, how much? Number of blocks equal to size by default block size. Size is 200 by 64. 4 blocks. First block of 64 MB, second block, third block, but fourth block will be of 8 MB only. First block stored in system 1, slave 1, B2 stored in slave 2, system 2, B3 in S3, B4 in S4. Means your data, your file divided into 4 parts, 4 blocks, and stored across 4 slaves, 4 systems, and are processed parallelly. I got one more file. See this f2.txt, 192 MB. What is the default block size? Means default, what is the size of each block? 64. Number of blocks equal to size by default block size. Size by default block size. Size is what? 192. Default block size 64.
So
192 is-
what about this free size 56 MB?
Yeah, 56 MB free. I'm coming to that one.
Okay.
192 by 64, 3 blocks. So here B5, B6, B7, 3 blocks, right? B5, 64, 64, 64, stored across 3 systems, 3 slaves, right? That's fine. Here the question is 56 MB of data is free in B4. Why B5 data is not stored in that B4? Why this B5 data is not stored in B4 means whenever you try to retrieve this file f1.txt, we need to combine all these 4 blocks, B1 plus B2 plus B3 plus B4. B1, B2, B3, B4. Whenever I am trying to retrieve these 4 blocks, assume if B5 data stored in B4, if B5 data stored in B4, if B5 data stored in B4, assume B1 64, B2 64, B3 64, B4 8 MB plus 56 MB of f2.txt data. Means you will get total size of 256 MB, but actual file size is 200 MB. Means 56 MB. I'm trying, whenever I'm trying to retrieve f1.txt, what you are getting? Some 56 MB of f2.txt data also you are getting, which is wrong computation, right? So that is when we are retrieving f1, we are getting a part of other files data. So every file should have its own blocks and things. Every file will have its own blocks. Design principles with respect to HDFS blocks. Every file should have dedicated number of blocks. First file has got 4. Second file has got 3 here. In a single block, no 2 files data to be stored. In a single block, no 2 files data to be stored. Every block has got equal value except the last block. Every block has got the equal value except the last block. So this design principles with respect to HDFS block. How exactly, right? Data storage and processing happening. I'm going to discuss 3 cases here. Case 1, observe this, how exactly data stored and processed. Now, case 1, if the number of blocks, if it is equal to number of slaves, 3 blocks, assume 3 slaves, B1, B2, B3, 3 slaves, S1, S2, S3, high speed. Yes, if the number of blocks is equal to number of slaves, blocks equal to slaves, B1, B2, B3, S1. Then high speed full parallelism you get. Example, f1.txt, what 192 MB is the size of this file. Default block size is what 64 MB. So that 192 MB file is divided into 64, 64, 64 size. Number of blocks equal to size by default block size. How many blocks? Size by default block size. Size is what? 192. by 64. 3 blocks. B1, B2, B3. B1 64, B2, B3. B1 stored in slave 1, B2 in S2, B3 in S3.
Sir, can we control the size? Suppose you have 200 MB file and there will be 4 block, right? So in each, like first block 60 MB, second 60, third 60, and the last is 20 MB. Can we do like that?
We can also configure the block size. We can keep our own block size. By
Okay.
default, it is 64 or 128. Even we can set our own block size. I'll show like configuring block size. 100 MB I can give 200 MB, 150 MB, right? This
Yes.
we can have our own custom block size. This how exactly data stored, your file divided into blocks. And these blocks okay, stored across the multiple slaves, right? Yes. And here data processing, right? Job is to process f1.txt. Job is to process f1.txt. Job always divides into task. Number of tasks, how many means? Number of tasks in Hadoop always depends on number of unique blocks. Number of tasks always depends on number of unique blocks.
So Vijay, I have a question. If we have a file of 500 megabyte and we have only 3 blocks, so then this will be divided among 3?
See, you're
Or
you're talking 500 MB file.
yes,
500 MB file divided by 64 MB. Nearly will get some, how many blocks? For 192, it is 336. Nearly 8 to 9 blocks you will get.
right.
9 blocks will be getting. So if there are 9 blocks, means number of tasks will be 9. Here 3 blocks, right? So number of tasks are 3.
So we have the ability to increase the number of blocks from 3 to 9 or 10 or
Yes, we can configure it by increasing or decreasing its size.
okay. All right, thanks.
So here we got your job is divided into tasks. Number of tasks depends on number of blocks. 3 blocks means 3 tasks, T1, T2, T3. Job is to process f1.txt. It has got divided into 3 tasks, T1, T2, T3. T1 is for executing B1, T2 is for executing B2, T3 for executing B3. 3 tasks, nothing but executing 3 blocks. Who should execute this T1 task? Try to answer. Who should execute this T1 task?
Slave 1.
Yes, slave 1 only, right? Because T1 is for executing B1, B1 present in slave 1. So slave 1 only executes. Who should execute this T2 task? Slave 2 only. Because task 2 is nothing but executing B2. Where this B2 is present? Slave 2. T3 is for executing B3, T3 for execute. So S3 executes this T3. Right? So here 3 tasks T1, T2, T3 are executed by parallelly by 3 slaves S1, S2, S3. Here no tasks are in the waiting state. 3 tasks executed by 3 slaves, right? Here no tasks are in the waiting state, right? Yes, just observe this diagram for this case 1. This is the master. These are slaves. Master node or name node we call. Master node or name node. Slave nodes are data nodes. Slave nodes are data nodes. Name node. Yes. So here f1.txt divided into 3 blocks. So B1 block by slave 1, B2 by S2, B3 by S3. Three tasks are executed by the 3 slaves parallelly. Okay.
So you had mentioned earlier that if one of the slave fails, then the other slaves will take the
Yes.
job,
Yes.
right?
Yes.
So if S1 fails, then the load will be divided between S2 and S3. So will that not
So
load
here
increase
your
things?
file f1.txt divided into 3 blocks B1, B2, B3. B1 is stored in S1, B2 in S2, B3 in S3. Executing this B1 has got some 10 lakh records. B2 also 10 lakh, B3 also 10 lakh, 10 lakh here, B1, B2 also 10 lakh records, B3 also 10 lakh. Once anyone, you said the first one is failed, means 10 lakh records are lost. 10 lakh records are lost and the T1 task also failed, right? Yes. How Hadoop is going to overcome this kind of situation means using concept like fault tolerance.
Okay. So fault tolerance mean that the new block will be allocated for this T1 task, or the T1 task load will be divided between
So here, no. Actually, to execute this T1 task, B1 block is not available in this slave 2, slave 3.
Okay.
To execute the T1 task, a slave 2, slave 3 cannot execute because the B1 block is not present in.
Okay.
So that B1 data is lost, 10 lakh records lost, T1 data, T1 task is failed. So I'll come back for the correct explanation.
All right.
First, so
Thank
here
you.
full parallelism, right? High speed. Full parallelism, high speed means 3 tasks executed by 3 slaves parallelly. None of the tasks are in waiting state. All are in running state, right? And full parallelism, very high speed. And secondly, see the case 2, right? Number of blocks are more than the number of slaves. 4 blocks, only 2 slaves, 2 systems. In this way. S1, S2. F1.txt, B1, B2, B3, B4. So B1 stored here, B2 here, B3 here, B4 here. So here, 2 blocks are stored in one system, 2 blocks are stored in one system in this way. Number of blocks is more than, less speed, less parallelism means. So here B1 in S1, B2 in S2, B3 in S1, B4 in S2. Job is to process, job is to F1.txt, number of tasks how many? Number of unique blocks. Number of tasks equal to number of unique blocks. How many? 4. So 4 tasks. T1, T2, T3, and T4. T1, okay, so 4 tasks, right? 4 tasks, T1, T2, T3. So number of tasks always depends on number of blocks. So 4 blocks, 4 tasks. Job is to divide it into 4 tasks, T1, T2, T3, T1 for executing B1, T2 for B2, T3 for B3, T4 for executing B4. Who should execute this T1? Slave 1, S1 only. T2 for executing B2 means B2 is present, slave 2 only should execute. Who should execute T3 task? Who should execute T3 task?
S1.
S1, right? Because B3 is present in S1. T4, right? T4 is for executing B4. So who should execute? Slave 2. Means here slave 1 should execute 2 tasks. S1 executing 2 tasks. S2 also should execute 2 tasks. Here while executing T1, while T1 is executing, T3 will be in waiting state. Here in slave 2, if T2 is executing, T4 will be in waiting state. Means here some tasks are in the waiting state. So less parallelism, less speed. Now observe this. More blocks. More blocks, right? Only one slave. Only one slave. No parallelism. In this case, no parallelism. No parallelism. For example, 4 works, only one. More blocks, only one slave. 4 blocks B1, B2, B3, and one slave S1. That S1 only should execute this B1, B2, B3, B4 blocks. So all these 4 blocks stored in S1 only. Number of tasks also 4. Who should execute this 4 tasks? T1 by S1, T2. Okay, here if we see, right? T1 by S1, T2 by S1, T3 by S1, T4. So 4 tasks are executed by single slave sequentially. So here no parallelism. So here no parallelism at all. Less speed, right? Yes. So in case 1, just okay, observe this case 1, right? I was just saying this example, right? In case 1, when 3 tasks are executed by the 3 slaves, if any one slave goes down, 2 drawbacks you observe, right? 2 drawbacks you observe. One is this B1 10 lakh records are lost, T1 task will be failed. So there is a huge loss, right? 10 lakh records lost means, and the job got failed means there is huge loss. How Hadoop is able to overcome means, in case 1, if multiple tasks are executed by multiple slaves, if any slave goes down, then we observe 2 things. Data is lost. S3 slave storing B3 block will be lost. Task is failed. That is S3 executing T3 task. To overcome this, Hadoop comes with a concept called replication and fault tolerance. So we're coming with a concept called replication and fault tolerance. So in tomorrow's session, my discussion will be totally on the replication, fault tolerance mechanism, and Hadoop architecture part, right? Architecture. So to overcome this, right, we have got replication and fault tolerance, right? Yes. Fine. So what is replication? What is fault tolerance? That we'll discuss in tomorrow session, right? Yes. Tomorrow also, same time at 3 o'clock. Same link you can follow, right? To see more on this, right? Fine. Any queries, right? So what is Hadoop? And okay, just I'll just give a quick introduction to, just I'll take 5 minutes more, right? Fine.
So is it 3 o'clock or 4 o'clock?
1 second. 1 second. 1 second. I'll come back to that. What is Spark? What is Spark? Why PySpark? Need for PySpark. Spark, Python versus Scala and PySpark features. A real-time usage of PySpark and PySpark job market. So I can say like Spark is a distributed execution with parallel processor style, with in-memory computation feature, open source cluster computing framework used for large-scale data processing, right? Distributed execution, your data is distributed and processed, parallel processing, you see. In-memory computation means data is stored within the memory and data is processed within the memory. Data within the RAM and processing within the RAM, right? Yes, data stored within the RAM and data processed within the RAM. Yes, and why PySpark? Why PySpark, right? Yes. So Python API for you to use Spark. Python API to use Spark. PySpark is a open source cluster computing used for big data solution, right? And PySpark is a lightning fast technology that is designed for fast computations, and it is a very demanding tool among data engineers, right, to work with bigger data sets. Right, it's PySpark mainly used for running distributed SQL, creating a data pipelines, ingesting data into a database, running machine learning algorithms, working with graphs or data stream, working with graphs and data stream. Right? Yes. Scala and Python, right? Yes. And for need for PySpark means, so what is the necessity for PySpark? So if you see large amount of data is generated both through offline and online, so this data will contain hidden patterns, unknown corrections, market trends, customer preferences, and other useful information, right? So it is necessary to extract the useful information, right, from this raw data. So we require some efficient tool to perform these different types of operations on the big data, right? So there are various tools to perform these multiple tasks on huge data set, but those tools are not so appealing, right? So it is needed to use some scalable and flexible tools to crack the big data and gain benefits from it. So PySpark is one such tool, right? So the combination of Python and Spark would be the very efficient way to the world of big data, right? That's why Apache Spark community came up with tool called PySpark. So most of them like Scala and Python, which one is mostly preferred for implementing Spark? So both are used. Scala is static type, by Python is dynamic type, means directly if we say x equal to 10, a variable x is created dynamically. But in Scala, we need to use that time, we need to specify the time. Scala is faster than Python. Python is little slower, right, as compared with Scala, but Python community is large. But Scala community is small. Scala has smaller libraries. Python has powerful library, right? And what are the features of PySpark, right? in-memory computation, storage and processing within the memory level. Lazy evaluated means just like functions. If you call them only, they get executed. Here also, if you perform action, then only the data flow gets executed. Powerful fault tolerance. Persistence means already executed transformation, again we can use it. Distributed executions and real-time usage of PySpark. Real-time usage of PySpark means Python. So this PySpark mostly used in this commercial sector, right? Like real-time processing, banks and other financial fields using Spark. Yes, to retrieve customer social media information and to gain useful insights that can help to make right decisions, right? And healthcare, right? In patients, analyzing the patient's records, the previous medical history or reports to identify which patient is going to face such kind of problem. Entertainment industry, right? So the popular entertainment industry like Netflix using Apache Spark for real-time processing with personalized online movies or web series. It processes what is that? Spark process nearly 450 billion events per day. Yes, in trades, e-commerce, in Flipkart, Amazon, right? Apache Spark is used for advertising. The other websites, even like in Alibaba, right? For enhanced customer experience and for recommendations, people who buy a particular product can also purchase other product, right? Recommendations. Tourism industry also advising millions of customers by comparing hundreds of tourism apps. Just a small introduction, right? PySpark has got great demand. So tomorrow my discussion will be on replication and fault tolerance. Fine. Yes. So any other queries, right? Anyone?
What are the timings of this class, sir?
So yes, we go with 1 second, 1 second. Tomorrow the session will be at 1 second. 3:30. Every week, right? We'll go with this time.
Okay. This is the first section, sir, or second
3:30
section?
3:30 p.m. to 5 p.m. This is whatever we have discussed, right? So this one, 3:30. Continuation of this. Tomorrow our session will be continuation this replication and fault tolerance, and it continues every week.
So this is the first section.
Yes, yes. Introduction to 3:30, right? Tomorrow it will be from 3:30 to 5:30. Tomorrow the session timing will be from 3:30 to 5:30, 2 hours, right? So my discussion will be replication and fault tolerance, right? Means if any task fails, then how to be able to overcome the other things, right? Yes. Fine. Okay. So you can follow the same link for tomorrow's session to see more on this, right? Fine. So I'm stopping for now. We'll continue tomorrow at 3:30, right? Yes.
Thank you for your time, Vijay.
Yeah, thank you, sir.
Yes.